Hi everyone, in the previous lecture we designed a microstrip patch antenna and then we simulated it, and you know that the parametric results have been obtained now. Now after obtaining the parametric result, we are interested in the S parameter of this antenna. To see the S parameter results, we will look into the 1D result here. We will open the 1D result and there is a subcategory which is the S parameter. We will open the S11 parameter of this microstrip patch antenna now. Now as you know that this was a single port antenna, so we can only get S11 result. This is the S11 result. And you can see that we have a range of frequencies on the horizontal axis, which is ranging from 1 GHz to 10 GHz as we have previously defined before the simulation. So we have obtained the S parameter results. As I have already told that we are interested in this frequency, which is 2.5 GHz. So we will again simulate this antenna from 1 GHz to 3 GHz. And you should know that on the horizontal axis we have frequencies in gigahertz, and on the vertical axis we have the reflection coefficient. So this is the reflection coefficient axis in dB, and you can see that at minus 10 dB we have obtained the S11 parameter spikes, which is quite lower, and we can say that this is best. As I have already explained the detail of S11 parameter in my first lecture. So now I will change the frequencies. So in order to change the frequencies, I will go to the 3D, and in the 3D menu I will go to the modeling, and then I will go to the simulation, and I will click on the frequency, and I will change the maximum frequency to 3 GHz, and I will click and OK, again OK, and you can see that now the frequency has changed. I will start the simulation, and model will take some time in order to simulate properly, so it will take some time. Now you can see that the simulation has completed, and as I told you that I am interested in the S11 parameter, so again I will go and I will open the S11 parameter plot. And as you can see that the frequency dip, which is the lower dip, it is near the 2.4 GHz. It is not at 2.5 GHz, so it is in between the 2.4 and 2.5 GHz frequency range. And on the vertical axis you can see that it is below minus 10 dB, so it is good. We can also change the color of this plot. We can just only click on this line, and we can go to the curve style, and then we can choose any color from this platelet. So I am going to color this in magenta. So you can see that the plot color has changed. We can change the line style. We can change it to dashed, dotted, or whatever we like. So I am going to choose the dashed one. So after applying it, you can see that the line has changed. I can change the line width as well. So I keep the line width as 3. So the line width has now increased. Now I can further increase it up to 5. So you can see that the width of the line has increased. So I can change the style of this line from here. I will press OK. So in order to find out the bandwidth of this antenna, we can add markers. So I will add the first marker at this point, which is vertically at 10 dBm, minus 10 dBm. And I can add another marker, right click on this and add another marker here at this point. And you can see here there are two data points which show that the lower frequency is 2.3924 GHz and upper frequency is 2.4931 GHz. We can also add some annotations, name, text in this antenna design. So we just only need to click here, right click and here, and we can add any text. Just click on here and just add annotation, and here in this text section I will write page and antenna. So I'll write patch antenna here. Patch antenna. Patch antenna operating at 2.4 gigahertz. So click on OK, and you can see that the text annotation has been added. I can drag and drop it anywhere in this plot. So I'm going to put it here. I can put it here as well. I can resize it as well. So this is the method. We can also change the x-axis values, like these x ticks can be changed. So just only we need to click on here, and we have to select the option which is the plot properties, and we will uncheck the auto ticks, and we can write here 0.5, and when we apply it, we can see that the number of ticks has reduced. So previously there were many number of ticks. Now there is a ticks gaps of 0.5. I can also change it to 0.3. You can see that there is a difference, or the gap between the ticks is 0.3. So you can change these horizontal text values, and you can see that the vertical lines, dotted lines, have some gaps of 0.3 gigahertz. We can also see that we have an option here at the top, reset view, which shortcut is space button. If I zoom it, or if I translate this plot into anywhere, and then I press the space bar button in the keyboard, it will restore its original shape. So we just need only to press the space button. Now if I zoom it here, you can see that the dip is not accurately on 2.4 gigahertz. So if in order I want to shift this frequency to operate on 2.4 gigahertz, then I will need to change these parametric list. I will change the values of this parametric list, and somewhere with some parameters this antenna will start operating at 2.4 gigahertz frequency band. Now in the parameter list, we already know that we have defined these parameters, which are the thickness, and PW mean the patch width, and we have the PL patch length, CT which is the thickness of the copper, and we have FW which is the feed width, FL which is the feed length. So we have a list of parameters. We can change it into any value and to get any type of result, and we can create any type of antenna by changing these parameters. But before changing these parameters with the hit and trial rule, we need to look into this option, which is parametric sweep. This parametric sweep tells us that which parameter has what effect on the antenna results. So we will look into the parametric sweep option in the next lectures. So up to this lecture, you have evaluated a design of patch antenna. Thank you so much.